NCERT Chemistry Solution Lesson, the topic colligative properties and determination of molecular mass. What are colligative properties? Now consider two containers, one containing 10 gram of sugar in 100 ml of water, the another one containing 50 gram of sugar in 100 ml water. Now we are boiling the two solution. The solution containing 10 gram of sugar boils first, then the top 50 grams of sugar. So the boiling point is one colligative property. It depends upon the number of solute particle present in it, not on the nature of solute particle. So boiling point is a colligative properties, depends upon the number of solute particle irrespective of nature related to the total number of particles present in the solution. Such properties are called colligative properties. So the colligative property, examples of colligative properties: relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, osmotic pressure are examples of colligative properties. So what are colligative properties and examples of colligative properties? The scientist Raoults established a relationship of the relative lowering of vapor pressure. How relative lowering of vapor pressure directly related to the solute particle present in it. Here the relative lowering of vapor pressure depends upon the concentration of the solute particle and it is independent of the identity. So the vapor pressure of the solution is directly proportional, the vapor pressure of the solution is directly proportional to the mole fraction of the solvent and the vapor pressure of the pure solvent. The reduction in the vapor pressure of the solvent present in a solution is always the difference in the vapor pressure of the pure solvent and the solution is delta P is equal to vapor pressure of the pure solvent and vapor pressure of the solution. That can be written as the P naught is the vapor pressure of the pure solvent. Vapor pressure of the solution can be written as vapor pressure of the pure solvent and the mole fraction of the solvent. So that can be simplified as P naught into 1 minus x1, vapor pressure of the solvent into 1 minus x1. So 1 minus x1 is equal to x2. x1 is mole fraction of the solvent and x2 is mole fraction of the solute. So the difference in the vapor pressure of the solvent and solution, the lowering of vapor pressure is equal to mole fraction of the solute and the vapor pressure of the pure solvent. According to Raoults, the lowering of vapor pressure depends upon the mole fraction of the solute and the vapor pressure of the pure solvent. So delta P is lowering of vapor pressure. Here delta P is lowering of vapor pressure, that is the difference in the vapor pressure of the pure solvent and solution. What is relative lowering of vapor pressure is lowering of vapor pressure to the vapor pressure of the pure solvent is called relative lowering of vapor pressure. That is, lowering of vapor pressure is vapor pressure of the pure solvent and the solution to the vapor pressure of the pure solvent, that is equal to the x2, mole fraction of the solute. So according to Raoults law, relative lowering of vapor pressure is directly proportional to the mole fraction of the solute present in it. So what is mole fraction of the solute? Mole fraction of the solute x2 is equal to number of moles of the solute to the number of moles of the solution, that is solvent plus solute is called solution. Number of moles of the solute to the number of moles present in a solution, that is called x2, mole fraction of the solution solute x2. When compared to N1, the N2 is negligible, that can be written as N2 by N1. Relative lowering of vapor pressure is number of moles of the solute to the number of moles of the solvent. That is, in turn, N2 is equal to molecular weight of the solute divided by the molecular weight of the solute. Number of moles of the solvent is equal to weight of the solvent divided by molecular weight of the solvent. Now substituting the value of number of moles of the solute solvent in this equation, we can get the relative lowering of vapor pressure is equal to W2 by M2 into M1 by W1. Here the W1 and W2 are the masses and M1, M2 are the molecular mass of the solvent. Relative lowering of vapor pressure is directly proportional to the mole fraction of the solute, in turn with the number of moles of the solute again into the weight and molecular weight. So the relative lowering of vapor pressure can be calculated by knowing the weight and molecular weight. Otherwise, by knowing the relative lowering of vapor pressure, the unknown weight and molecular weight of the substance dissolved can be calculated. So according to Raoults law, the relative lowering of vapor pressure is directly proportional to the mole fraction of the solute, and lowering of vapor pressure is equal to the mole fraction of the solvent and the vapor pressure of the pure solvent. So what are colligative properties, and give example what is Raoults law and how Raoults law is verified, and what is lowering of vapor pressure and relative lowering of vapor pressure. According to Raoults law, at final the relative lowering of vapor pressure is equal to the mole fraction of the solute. Subscribe for more videos. Thank you.